Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we are going to discuss a multiple choice question and the question is in front of you. Okay, so such kind of questions are very important for exams like CSIR-NET, GATE, IIT-JAM, means B.Sc, M.Sc, BSMS equivalent exams. Okay, so I suggest you please try to solve the question clearly, and if you are not able to do it, please watch the video completely and learn. First of all the chemistry, second of all the strategy I shall explain. So the question is, in presence of dilute acid, what is the major product structure? And in order to get the answer, 4 options are provided in front of you and one of them is the right answer and you have to find it out. As usual, I first request you, please pause the lecture and try by yourself, and write your answer in the comment box, because self-evaluation is essential for self-improvement. Okay, so you should know your strength as well as weakness. So definitely I think you have tried by yourself, you have paused and you have tried. So now let's discuss what is the answer, and I request you, please watch this problem with a cool mind and watch the video completely, because the problem is not that much easy, but if you learn it properly, you've learned the art to solve the problem properly, I believe you will not face any difficulty during the examination. So let's start. As usual, first learn about the nature of the reagent such that your chemistry skill or chemistry realization or philosophy about chemistry improves, such that you become eligible to solve any kind of difficult problem appear in the exam if you know the basic chemistry properly. First of all, look at the molecule. It's an interesting molecule. Actually, this molecule has lots of cyclopropane ring, point number 1, and it has a tertiary hydroxyl. Okay, tertiary hydroxyl group, and which is we know that tertiary alcohol are prone to dehydration in presence of acid, better to say diluted acid. I have already discussed a dedicated lecture, dehydration of alcohol in presence of acid and generation of carbocation. Okay, please visit. And after dehydration, what it can produce? It can produce a tertiary carbocation which is relatively stable, and tertiary carbocations are stable because of plus I and hyperconjugation. And I have uploaded a dedicated lecture based on the comparison of stability of comparison of stability between a tertiary carbocation versus a benzylic carbocation, means the plus I and hyperconjugation versus plus R effect produced from the phenyl ring. Please visit. And the most important thing which you have learned previously, that carbocation can undergo rearrangement condition if the final product carbocation is more stable than the reactant carbocation. Okay, so please keep these points in your mind. I believe you will be able to solve the problem. Now let's discuss the mechanism. So what happens in the first stage? First stage, the tertiary alcohol undergo protonation, which is present as H3O plus in the medium. So this, and after protonation it is prone to elimination, and it resulted in a tertiary carbocation formation, which is actually, better to say, relatively stable. Now if it is relatively stable, well, it will undergo reaction. As I told, if another kind of stabilization possible after reaction, and obviously this is possible from this cyclopropane ring, because it's a 3-member ring, it is strained. So is it possible that it can somehow reduce its strain? Yes, obviously yes, this can migrate. Okay, and after migration, what it produces? It produces another carbocation, but it was a 3-member ring. So from 3-member to what we are getting, 4-member. So what is overall happening? The relief of ring strain. Relief of ring strain occurs. So consequently, what is the benefit? Actually both are tertiary. this is tertiary, but if the ring strain is relieved somewhat, so that's the stabilization, and that is the driving force for this reaction. Now look at this, it is just previous, this is a carbocation, in the next stage a cyclopropane ring. So similar process is possible, and this thing will continue until all the cyclopropanes are consumed, means the final product is this one. This I will come to the stereochemistry up down later on. So next, what can happen, that water molecule can act as a nucleophile, means here, and it will result in an alcohol. By the way, a simple question may come in your mind that, sir, it was a carbocation and its alpha position hydrogens are there, this is, so why doesn't it undergo elimination of proton to prepare alkene, instead of that it undergo water addition? Just look at it, logically accept that if it undergo elimination, it will prepare a double bond, and that is a cyclobutene derivative, strain not stable, point number 1. Second point is that for elimination, so first of all, for elimination some drastic condition like heat is needed. Did I provide any heat? I have provided just diluted acid, so it's will not undergo elimination under this condition because of this two reasons. First of all, the strain, so first of all strain, and second is the for elimination heat needed, which I haven't provided. This is the first description. Now let's discuss little bit about the stereochemistry. Just look at the molecule carefully. First thing, when the migration happen, so this part up to it's pretty fine. Now this is a planar species, carbocation, so the bond can migrate from both sides with equal probability, fine. But after migration, what it will do? It will do this. Now see, these two bonds cannot come in the same position because it is a sp3 carbon, and we know the angle is near about 109 degree, not possible. Now we have understood this. Now first is up, we understood. Just look at second is down, because if both are in the same side, then extremely steric strain, it is not actually possible that same, means what do I mean, these and these bond come same, and we know that rings are always cis. There are some exception for macrocyclic rings, say trans double bond means possible, but generally for small member rings it is always cis. Okay, for small member ring. So what is the advantage? What that this cannot come to the same direction, so it should be alternate to cis and trans. Okay, I guess you have understood this, and finally the reaction will end up here and the alcohol will add. Now by the way, alcohol, since this bond is in the upside, the alcohol is expected to be added from the downside. Okay, but I haven't mentioned. So what is the answer of this problem? So answer is this one. Now I know this problem is little difficult from when you observe, and this is actually a difficult problem, I agree with you. And when such kind of difficult problems are given, examiners used to choose options which are relatively stable, relatively easier, and if you know tricks, better to say the common sense about chemistry or chemical understanding, then you can solve the problem very easily. How? Just look at this, in 30 seconds you can solve if you follow these tricks. So first of all, it's protonation, fine. After protonation, what it will result? After protonation, it result in a carbocation. First of all, this is a tertiary but attached with a cyclopropane, so it will move. Again the positive charge will come here. Then if it is, then again this cyclopropane move, and how long this will go on until all the cyclopropanes are consumed. How many options are there where all the cyclopropanes are consumed? Only one. So you don't need to think about elimination, addition. This is the answer. Because others options, this double bond is not logical, because elimination not possible. I have provided only H3O plus. So these two double bond option gone. And finally one double, means first of all one migration, that is also not true, because all the cyclopropanes are strained and the cyclobutane having relatively lesser amount strain than cyclopropane as its ring number increases. So this is the answer. So if you don't know the answer properly, also based on your common sense, you can find out the right answer. So remember, in life common sense is very important, and the sad thing is that the common sense is very uncommon. Okay, leave it. So in conclusion, what we have learned today? We have learned today about the tertiary alcohol and prone to dehydration in presence of acid. Better to say they are prone to dehydration in presence of milder acid. Okay. And another important information, let me tell you, by any reaction, for example, Grignard reaction with ketone. Okay, if you do this reaction, what it will end up? It will end up a tertiary alcohol. Means better to say O minus MgX. This is plus, and after workup, you get the final tertiary alcohol. Just remember that this step need to be done very carefully, and acid need to be very diluted. Otherwise, the produced tertiary alcohol undergo dehydration. Means undergo dehydration to produce carbocation, and carbocation can undergo different reaction. So these tertiary carbocation are, means better to say these tertiary alcohols are very delicate to be handled in presence of acid. Okay, fine. Now tertiary carbocation are relatively stable, but they can undergo rearrangement to another tertiary alcohol very easily if some additional stability factor available. Okay, so this additional stability is the main reason for this reaction, and in this case what's happening, because this cyclobutanes are relatively stable than cyclopropane because of relief of ring strain. Okay, and the last but the most important point from this today's discussion is the nucleophilic addition on carbocation can occur under normal condition, but elimination from the carbocation needs some drastic condition. Okay, so this is the end of this discussion. I believe this video is useful for you. If it is, please give your feedback. First of all, I want to thank you for watching this lecture, and if you really like my teaching, please like the video and make some and write your opinion in the comment box. And finally, if you think this video is worthy, then share with your friends so that they can also enjoy the benefit. And most importantly, subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon such that you get the notification of every new single video I upload. So before going, stay happy, stay blessed, stay cool, enjoy the beauty of chemistry, and make your understanding level to a superior stage. So thank you again. See you in my next video.